All right, back here with a couple more examples. We'll see how many we get done here on section 4.2, the standard normal distribution. And we have it here. Assume that the readings at freezing on a batch of thermometers are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1. A single thermometer is randomly selected and tested. Find the probability of obtaining a reading between negative 1.67 degrees Celsius and 2.562 degrees Celsius. And here we have it in sort of math symbols. So again, we're kind of stressing drawing a picture, so I'm going to do that here. And again, we just kind of want to have a general understanding of what's happening, so don't sweat it if your picture is not perfect. Anyway, there's our standard normal distribution. And we have a negative 0.167, which would be over here to the left a little bit. Negative 0.167, that's probably even a little too far. And then 2.562, somewhere over here. And what we're doing here is we're finding the probability of getting a number in there. So there's our picture. Now to do some work. Now remember, our normal standard distribution function, if we use true, gives us the area to the left. So what we're going to do here, we'll find the area to the left of 2.562, which is all of this, and then we'll subtract the area over here to find that area in between. So you might hear me say stuff like, well, take my high side value and then subtract my low side value, because we're trying to find that area in between. Now I'm going to do it in 2 steps here. I'll just find the area to the left of 2.562 first. And this might mess with my scale a little bit. Okay. So to do that, it's a normal standard distribution. I just put in the z-score, 2.562, and go true. Now this should be kind of close to 1 because it's all this area to the left. Now we're going to want to round to 4 decimal places, so I might need to make this a little bit bigger so that I have some more precision. So this is all the area to the left of here, including this part we don't want. And then I'll find the area of my low sides, so less than negative 0.167, I believe it was. Similarly, normal standard distribution, negative 0.167, true. And remember, the area to the left of 0 is about a half. So this kind of makes sense, right? If we're over here, we're going to be a little less than half for this area. So then this area in between, so negative 0.167 is less than z or x and 2.562. It's going to be the difference of these. So I'll take the high side value and subtract the low side value, and we get 0.5611. Now, we can do this in one shot also. If I want to do this normal standard distribution function and take my high side value and then subtract the normal standard distribution of the low side value. This will work if I don't put in that other, oh, I needed comma true, huh? I was just concentrating on the keyboard there. Anyway, so this gets us in one shot, and perfectly fine to do that if you want. Just sometimes for understanding's sake, it's nice to break it down into a couple of little steps there. So there's a problem worked out. I'm doing a few of them. So these are all kind of left, right, between, something like that. Here it is, just a different way to write the same kind of problem. Here, this is a right-hand side problem, a left side. All right, so now it says for a standard normal distribution, find the probability of z less than c equals 0.932. So this is a different kind of question, which is why I sort of went over to it. And what we have here in this situation is now we're looking for a number along the x-axis. So z is less than c, gets us 0.932. So here's my normal distribution, a little curvier this time. So I've got a c over here somewhere, and this area to the left is 0.932. So now we have an area, and we're looking to find a score. So we're essentially looking for a z-score here, and when we do this, it's going to be normal, but it's going to be a normal standard inverse, and we just need to enter the area to the left here, 0.932. And so now we're getting a z-score with a cutoff, so that the area to the left of it is 0.32. And so we get 1.49. A lot of these are rounded to 2 decimal places. Again, that comes from when we had to use tables for these, but now Excel can do a lot of cooler stuff. Now, these can be a little bit confusing as you're reading them. So that's why it's, again, important to have the picture. So find a standard normal distribution, for a standard normal distribution, find P of Z is greater than C equals 0.1791. Find C rounded to 2 decimal places. So again, try my picture here. Oh, well, zoom in. Then I'll grab this. I'll try doing this with the mouse so you can see how it looks. Actually not terrible for this guy. Anyway, so I've got Z is greater than C is 0.1791. So now I got a C over here, and this area is 0.1791. Pretty rough using the mouse there, but I'm kind of expecting you to do it, so it's okay. So again, we're looking for a z-score, a score along the bottom. It's actually going to be a C. And now I've got the normal standard inverse. Now this probability here is the area to the left. I don't know that, so I can just let Excel do some work and say 1 minus 0.1791. Remember, the area under this curve is 1, so if I have the right-hand side, I can do 1 minus this area to find this left-hand side, and I could do this work at a different point. Here. Oops. I could find the area to the right by doing 1 minus 0.1791 and kind of labeling that over here 0.8209. And then I can figure out that same cutoff z-score, normal standard inverse, 0.8209. And the nice thing about the normal standard inverse is it just has one, there's no true false action, so we're just entering the probability. Anyway, we're rounding this to 2 decimal places, so 0.92. Anyway, again, it's important here, draw a picture. That way, if you happen to not get it correct, I can still sort of understand what you're doing and give you some partial credit. It's going to be important here to understand, are we getting a value here along the x-axis, a z-score, or are we getting a probability up in this region? Remember, probabilities are limited between 0 and 1, and z-scores, 99% or 99.97%, something like that, between 3 standard deviations. So if you're getting really large numbers and really small numbers, you might have made a mistake. Good luck. Let me know if you have any questions. Thanks for watching.